Welcome to qnawire.
In this question, we are told that 40% of all workers would change jobs for a slightly higher pay. 88% of companies say there's a shortage of qualified job candidates. Now, at first, we are picking 16 workers at random and looking at the number of these that change jobs for slightly higher pay. So the probability of each of these saying yes would be 40%, 0.4. And we want some probabilities here for parts A and B. Now, this is a binomial distribution. It meets all of the requirements. N independent trials, each worker in the sample. 2 outcomes for each, they would or they wouldn't. Same probability P that each person would. And to find this, you could use a binomial formula, which would take a while. You could use the distribution tables, like in the back of your textbook, or you could use technology. I'm going to use Excel with the binom dist function. It has 4 inputs: x, the number from a sample that meet this criteria, n, p, and whether or not you want the cumulative function. So in part A, 9 or more. So probability that x is at least 9. I can't immediately put this in. Cumulative is at this point or below, not above. But I can apply the complement rule, which is that if you add up the probability of an event and the event not happening, then the sum is 1. So you can start at 1 and take away the probabilities you don't want. We want at least 9. We don't want x to be 8 or fewer, which I can put in as 8. 16, 0.4. True, I do want cumulative. This gives me my answer, 0.1423. Part B, 3, 4, 5, or 6. So I can write that like so. X is between 3 and 6 inclusive. I'm going to rewrite that as x no more than 6 minus x no more than 2. If you think about which values of x are included in these, this one is 0 to 6, this one is 0 to 2. If you take these away, you're left with 3 to 6, which is what we need. So we're going to have 6, 16, 0.4 true, minus 2, 16, 0.4 true. To get 0.50, make some space over here, 88. So that's the first 2 parts. Now we're going to change this slightly to looking at companies with the second piece of data we were given. So now we have 13 companies contacted, so there's n. Probability each of them cannot find job candidates is 88%, 0.88. In part C, exactly 10 say this. So we put in 10, 13, 0.88, and false. For the first time so far, we don't want cumulative. Cumulative would be 10 or fewer. We just want exactly 10. And that is 0.1376. Part D, all of them say this, all 13. So you could use the function again, but this is actually the same thing happening 13 times in a row. Probability they say this multiplied by itself 13 times, which we can do because these are independent trials, which is 0.1898 to 4 decimal places. Part E, the expected number. That would be the mean of this distribution. The mean of a binomial is NP. We know that 88% of companies feel this way. So on average, 88% of our sample will feel this way. 13, times 0.88 gives us a mean of 11.44. On average, that is how many companies in a sample of this size will meet this criteria. course, it's only an average. If you were to look at many, many, many different samples, this is the average number in a sample that would meet that criteria. No actual sample can have point of a company. Agree.